So here's a second example, and I need you to really, really pay attention to this example because it's going to react with itself, and you have to see the reaction occurring and determine what attacked what. So in this case, you have three possible enolates. Okay, here they are. You can form an enolate here at A. You can form an enolate at B here. I'm just going to number them as A, B, and C, and there at C. So you have three possible enolates. And you have to actually draw the possible products. Okay, and then when we draw the products, we can determine which one is the favored or the major product. Okay, so let's begin with A. Let's make A the enolate. Okay, so here's the enolate. Tag the carbonyl carbon, the electrophile. So let's look at the product. Okay. Highlight them. This is going to help you. Count would help too if you count. Okay. So let's begin. So start with the aldehyde here. I'm drawing it this way because you're going to be able to see it. So it's coming, imagine that it's reacting and then this molecule is closing in. Okay, so here's yellow. Here's green. Now, let's draw what's on the green here. So we have an OH, remember, this becomes an OH. And then, of course, we have the CH3. And now the rest of them, so you have 1, 2, 3, and 4. So here it is. So take a look at it. It's can be difficult to see at first, but you can see that this formed a ring. It closed the ring. So these are all in between. So I'm going to number them for you here. I'm going to number these as 1, 2, 3, and 4. So 1, 2, 3, and 4. Okay. Now let's do B. Let me just redraw this a little bit here, make it bigger. It's not working with me. I don't know why. Let's see. Okay, so we said B will be the enolate. And it will attack the carbonyl carbon on the left side. Okay, so we need to color them. This is yellow. And this is green. Okay, so draw your ketone. Screen keeps disappearing. Not sure why. Okay, here we go. Okay, so let me draw the yellow and the green. So here's the yellow. And there's the green. And if you would like to number these, this is again going to be 1, 2, 3, and 4. You can number this as 1, 2, 3, and 4. Okay. Finally, is what if you have C? The CH3 as the enolate. Okay, so notice the difference now. It's 2 carbons over now. So you're going to have a bigger ring forming. Okay. Let's do this. So now this is going to be inside the ring. So yellow. And green. Okay. So let's begin with this. So we have okay, let me redraw this. Maybe we can work with this. Okay, so we have okay, here we go. So we have OH here. So we have now the carbonyl. Okay, so I'm going to show you here. We're going to discuss these in class 2. So here's yellow and here's green. And if you were to count these as 1, 2, 3, 4, 5, they would go this way. 1, 2, 3, 4, and 5. Okay, so what do you form? You form an 8-membered ring. All right, so which of these would be the best outcome? And the answer would be the middle one, where the enolate is formed here. And the reason why is because you have an aldehyde being attacked. So here you have an aldehyde attacked. And you also, plus, you formed a 6-membered ring. Whereas if you have, in the first one here, what was attacked? What was attacked was, and ketone was attacked. So what happened here is you have a ketone being attacked, and remember, ketones are not favored at equilibrium being attacked because they're more sterically hindered. So here's a ketone being attacked versus an aldehyde being attacked. So here you have a ketone attacked. You did form a 6-membered ring. But not favored at equilibrium. And finally, you have an aldehyde attacked here, but the problem is that you formed an 8-membered ring. Which is not favored. We need a 5 or a 6-membered ring. So therefore, this is the major product.